All right, number 3, we want to determine how many one-to-one correspondences we have between these two sets, M, Y, Z, W, V, and 1, 2, 3, 4, 5. Okay, so again, what we want to do is take each term from one set and pair it to another one. All right, so let's just do this. I'll kind of show you what's going on. M, Y, Z, W, and V. All right, each of these, put Z twice, it'll be a V. Okay, each of these letters are going to be paired with one of those numbers, 1, 2, 3, 4, 5. Okay, so for M, I could pair it with any one of those numbers, 1, 2, 3, 4, or 5. So there are 5 choices. I'm not saying that I'm pairing M with 5. I'm saying I have 5 possibilities, 1, 2, 3, 4, or 5. Okay. Okay, so let's say I paired it with the number 2. Okay, so 2 is out. It's already been matched up. Now when I use Y, I have 1, 2, 3, 4 choices. Okay, so I have only 4 options, and let's say I pick one of those. Now for the next term, I only have 3, and then 2, and then 1. Okay, so each time I use a letter, I don't get to use it again. And so this one has 5, 4, 3, 2, 1, and you multiply these all together. Okay, another way of denoting this is called 5 factorial, if you've ever seen this. I know it's an exclamation point, but in math it's called factorial. And it just simply means to take that number and multiply it by each number until you get to 1. So keep counting down. So 5 times 4 times 3 times 2 times 1. 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. Times 1, this is 120. Okay. If you have one of these graphing calculators, I can show you how you can input 5 factorial into that. You even have a scientific calculator, it should have it. But I'm going to turn this on, type the number 5 in, and if we go to math, and then we're going to arrow back, I really want to go to probability, so you can arrow right 3 times, or you can arrow back once and you'll get there. And notice option number 4 has that factorial symbol. So first you type the number, then you go math, probability, and number 4, and then when I hit enter, we get 120. So there are 120 ways there are 120 one-to-one correspondence between the sets F if M must match with 4. Okay, so I made a mistake. This would be if you were matching each letter. Any letter could be matched with any letter. Okay, you would have 120 if you're doing the whole set. However, we do have a restriction. This says M must match with 4. Okay, so let me show you the difference here. We have 1, 2, 3, 4, 5. Okay, so this letter M has to match with the number 4. 1, 2, 3, 4, 5. So that takes away my options for M. M only has one option. It can only be matched with 4. And then my next letters, I have 4 choices, 3, 2, and 1. And you're still going to multiply all of these together. So we'll do 1, and then 4, 3, 2, and 1. So if you just multiply 4 and 3, we get 12 times 2 is 24, and so we get 24. Okay, multiplying by 1 won't change it. So instead of 120 for this example, we get 24. So I gave you a little bit of extra information, but it's okay. Okay, now part B says we want to know how many one-to-one correspondence there are. If M must match with 4 and Y must match with 3, so similarly, we're going to say M and Y, we have taken away their choice. They only have one partner that they can line up with. And then the other 3 have free reign, so we have 3 choices, 2 choices and 1 left, because out of 5 we've taken 2 out, and we have 3, 2, and 1 left. Not saying that 3, 2, and 1 are the numbers, but they have 3 different options. So 3 times 2 is 6, times 1 is still 6, and times 1 2 more times is still 6. Okay, so we get 6 if we restrict 2 of them. All right, and then C, we want to know how many one-to-one correspondence there are if M, Y, and Z must match with an odd number. Okay, so M, Y, and Z have to match with an odd number. Okay, so let me make some space. Okay, so we'll have 2 different groups. 1, 2, 3, M, Y, Z. So out of 1, 2, 3, 4, 5, we have 3 odd numbers. 1, 3, and 5. These guys have to match with an odd one. And then the other 2, W and V, are going to be paired up with the even ones, 2 and 4. So over here, for M, there's 3 odd numbers. I can pick any one of them. It just says odd. So I have 3 choices here. Once I use one of them, this one only has 2 options. And then he is stuck with whatever's left. Okay, so we're going to multiply 3 times 2 times 1. All right, and we also have to multiply what we get over here. So W and V, they're going to be paired with the even. We have 2 options for W. Once I use one of them, I only have 1 option left. So we'll multiply 3 times 2 is 6, times 1 is 6, and then times 2 is 12, times 1 is still 12. So we'll have 12 ways to pair these up if these have to be matched with an odd, which consequently means these guys will be paired with an even.